Hello everyone, welcome back to my channel. I'm Purnima from Sri Venkateshwara College of Engineering. Currently, I'm studying in first year BE, second sem. Today, I'm here again to discuss about mathematics, in that graphs and networks. So let's get in. So in this video, we are going to learn about what is graphs and networks, the types and applications of graphs and networks, graph representation and data structures, and finally the network analysis. So firstly, introduction to graphs and networks. Graphs and networks are powerful mathematical tools used to model and analyze complex systems. They consist of nodes connected by edges representing the relationship between different entities. This structure is very simple, consisting of a number of dots that are called vertices in graph terminology and called nodes in network terminology. Between some of these dots are lines that are called edges in graph terminology or links in network terminology, as shown in the figure. Network terminology is generally used in situations where you want to think to transporting or sending things along the links between nodes, whether those things are physically objects or information. Graph terminology is more often used in situations where you want to the edges or links to present other types of relationships between the vertices or nodes. An example that has gotten some attention recently is the interest graph, in which the vertices are people and topics, and each edges links a person to a topic that they are interested in. You might say that a social network should really be called a graph since we often think of it in terms of the relationship between people rather than the status updates and tweets that get sent between them. In practice, there is no precise rule for deciding which term to use, but luckily it isn't too hard to keep up with both types of terminology. Graphs terminology and concepts. First one is nodes and edges, second one is degree and adjacency, and third one is paths and connectivity. Nodes and edges. Nodes represent the fundamental units such as people, locations, or devices. Edges represent the connections or relationship between these nodes. Degree and adjacency. The degree of a node is the number of edges connected to it. Adjacency refers to nodes that are directly connected by an edge. Paths and connectivity. A path is a sequence of connected edges, and connectivity describes how easily nodes can reach each other through these paths. Types of graphs and networks. There are four types are there. Uh, Undirected graphs, directed graphs, weighted graphs, and bipartite graphs. First one is undirected graphs. These these are edges have no directionality and connections are symmetric. Second one is directed graphs. These are edges have a specific direction representing one-way relationships. Third one is weighted graphs. Edges have numeric values representing the strength or cost of the connection. Fourth one is bipartite graphs. These are nodes are divided into two distinct sets with connections only between the sets. Graph representation and data structures. Uh, First one is adjacency matrix, second one is adjacency list, and the third one is edge list. Adjacency matrix, a 2D array representing the connection between nodes with 1s and 0s indicating the presence or absence of edges. Second one is adjacency list, a collection of lists where each list contains the neighbors of a particular node. Edge list, a list of pairs where each pair represents an edge connecting two nodes. Graph traversal algorithms. Breadth first search, commonly BFS, explores all the neighbors at the present depth before moving on to the neighbors at the next depth level. Depth first search (DFS) explores as far as possible along each branch before backtracking. Topological sort arranges the nodes in a linear order respecting the direction of edges. Descartes' algorithm finds the shortest path between a node and all other nodes in a weighted graph. Shortest path problems. Three types are there. First one is single source shortest path. Second one is all pairs shortest path, and the third one is negative weights and cycles. First one is single source shortest path. This is finding the shortest paths from a single node to all other nodes in the graph. Second one is all pair shortest path. It is determining the shortest path between every pair of nodes in the graph. Third one is negative weights and cycles. This is dealing with the graphs that have negative edges with an weights and potential negative cycle. So, what are networks? Networks are just graphs. They are described by a set of nodes and a set of lengths between nodes. They are often described using summary statistics such as the average degree. The degree of a node is the number of other nodes to which it is connected by an edge. The density of a network is the number of edges divided by the possible number of edges. Here we mostly look at examples where edges are single, undirected and unweighted, and there are no self loops. Network analysis and centrality measures. Degree centrality. It measures the importance of a node based on the number of its connections. Betweenness centrality. It quantifies the number of times a node acts as a bridge along the shortest path between two other nodes. Closeness centrality evaluates the average distance of a node to all other nodes in the graph. Invector centrality. It measures the influence of a node based on the importance of its neighbors. Finally, the applications of graphs and networks. Social networks, it helps to analyze the relations and influence between users. Transportation networks, optimizing routes and flow of traffic or goods. Biological networks, it helps to studying interactions between proteins, genes, and cells. Computer networks, it modeling the structure and communication patterns of the internet. So thank you for watching.